Good morning. Today we are continuing on using those different operations with adding, subtracting, multiplying, dividing. We had been doing expressions. Now we're moving into solving equations. So what's the difference between an expression and an equation? Jude? The equation has the equal sign. So we're going to be using that full equation now. So we're doing Po39. I can solve an equation with addition or subtraction. So what do you think of when you hear the word algebra? Most people think about solving for a variable. And we were working with putting in those numbers for those variables. There's so much more to it than that, but variables are a big part of it. So here are 3 ways we might think about how to solve a basic equation, and we're going to use whichever method works for us. So we're going to learn all 3 methods, and in today's objective and tomorrow's objective, or next week's objective, the next objective, we will be using which method works for us. As we get into more complicated equations, we're going to narrow it down to which method we have to use. As it gets more complicated, we have to use the more mathy way, where we write it all out and we stay organized. And we'll see why as we get more complicated. So let's look at our first equation. N plus 12 equals 19. Well, we have the logic way to solve this, where we can say, well, what number plus 12 equals 19? 7. Right? Some of this, when we use the logic, it's because it's easy numbers that we can do mental math with. So you're going to use the logic method when you can do mental math, right? And that's the question you're asking yourself without realizing it. You see n plus 12 equals 9, and your brain just automatically thinks, well, 7 plus 12 equals 19. Right? So we're asking ourselves the question without even realizing we asked it. So the logic way is asking that question and then just writing down the answer, because we can do mental math. The second way is called opposite operations. Now, some of us have been coming up to ask me for help on our math packet for the second word problem with the 3 people who had 51 books and how many did each one do. And I've asked some people, I'm like, have we done opposite operations in here yet? And people said no. This one is going to help us with that. And you'll see, when I do the packet video, you'll see how that opposite operations can come up with this. So opposite operations mean we do the opposite of PERMDAS. We're going to do SADMER. So instead of PERMDAS, we do it opposite. So we do the opposite of adding or subtracting first. Usually that's the last step we do. This time, when we're doing it opposite, if it says to add, we're going to subtract. So we always do the adding or subtracting first. Then we do the dividing or multiplying. Then we do exponents or radicals. And then usually the parentheses don't fall into them. We'll talk about parentheses when we get into way more complicated math. We don't work with it in Math 6. So the opposite, so let's show what that means with our equation of n plus 12 equals 19. What operation is happening right here? Jack?
Addition.
Addition. What's the opposite of addition? Rhoda?
Subtraction.
Subtraction. So our whole objective that we want to do is get n by itself. We want to know what n equals. So we need n on one side of the equal sign, and we need the answer on the other side. So we need to move whatever isn't n over to the other side. And we can't just take it and put it on the other side. we have to do opposite. We have to zero it out on this side when we're adding or subtracting. So what do you think we're gonna do if it says plus 12? What would that opposite operation be, Fernanda?
Subtract 12.
Yeah, and we have to do whatever, just like with fractions, whatever you do to one side, you do to the other side. Same thing with opposite operations. So if we have plus 12, we're gonna subtract 12 to both sides. So here, 12 minus 12, that zeroes out. So we get n by itself. Now over here, we had 19 minus 12 is 7. Oh, look at that. We found our answer. As we get into more complicated math, this is the method that we're going to work down to using. Because math is going to get too complicated to be doing it with just logic. Okay, we can't just do mental math. Math gets really big and complicated. So for these first two objectives working with this, we're able to do the logic or the fact families because it's easier numbers. But as we go through this and when we get into pre-algebra and algebra, and oh my goodness, when we get into calculus, it's going to matter that we know how to organize and set up our problems using the opposite operations. So just know, even if you don't use it in this objective today because you don't need to, you're going to have to learn it. It's coming. Our last method is called fact families. So we know we have addition. We know we have 12 and 19. So we can write out all the different facts here. N plus 12 equals 19, 12 plus n equals 19, 19 minus 12 equals n, and 19 minus n equals 12. So think about those fact families. 2 plus 3 equals 5, 3 plus 2 equals 5, 5 minus 2 equals 3, 5 minus 3 equals 2, right? Does that make sense, how we're doing the fact families, the two additions and the two subtractions? Which one of these fact families is going to be the most helpful for us to solve what n equals? Alex?
19 minus.
Yeah. 19 minus 12 equals n. That's going to be the most useful. Because we know 19 minus 12 is 7. And that is n. So we know n equals 7. So you can use the fact family to figure it out. You can use mental math with the logic, asking the question. Or you can use opposite operations. Now some of us might be saying, that opposite operations is a little confusing. That's okay. We're going to be working with it every day. It's going to click. Okay. So if it doesn't click today, use one of our other methods and it will start to click as we go through it more and more. Michael.
So if there's a negative number, you just add instead of subtract?
Yes, because negative means subtract. So the opposite of subtract is add. So. All right, so let's practice with these methods. We're going to practice using all three on this page. We have 3 of them. We're going to do it together so we get an idea of how all 3 of them work. When we get to our second page, you're picking your method. Okay? But together, we're going to do all 3 methods. So I want us all on this first page, all practicing all 3, especially the opposite operations, because the more we do it, the more it's going to click for us. And I know what's coming up. I know that we need to understand it. So we need to practice it. Our first method is the logic question. 14 plus n equals 25. What is the logic question that we would ask ourselves? If we're going to do that mental math, what would we ask ourselves? Michael?
25 minus 14 equals what?
Close. That's actually the fact family. because you're flipping it around and you're moving it around. So you said for the fact family, 25 minus 14 equals what? What is 25 minus 14, Michael?
11.
So that would be the fact family, when we move it around, using that number sense, being able to say, okay, instead of adding, I'm gonna subtract. Can anybody figure out what the question for the logic would be? Jack?
Is it 14 plus 40 equals 25?
14 plus what number equals 25? So 14 plus what equals 25? Rhoda, 11. We get the same answer. When it's asking the question straight up, 14 plus what number equals 25? The fact family, Michael flipped it around to find the one that would give us the answer, 25 minus 14. Then we have our opposite operations. So I'm going to rewrite my equation. 14 plus n equals 25. Who thinks they know what to do? Rhoda.
You take 14 away from 25 and 14?
Yeah. This is a positive 14. I don't see an operation in front of it, but I know it's a positive number. It doesn't have a negative in front of it. Positive means plus, means you're adding. Negative means you're subtracting. So if this is a positive number, the opposite of it would be to subtract it. The whole point is we want to zero it out. 14 minus 14 gets us to 0. Whatever I do to one side, I have to do to the other side. 25 minus 14 is 11. I bring down what I haven't used yet. I don't need to bring down 14 minus 14 is 0. 0 plus a number is still going to just be the number. So I don't have to write 0 plus. I know it's just the number, and then I bring down what I found there, and we get n equals 11. Let's try our next one. What would be our question, our logic question we would ask? N minus 16 equals 4. What question would that be? Shantrea?
16 minus 4 equals 9.
Careful. If we're going to flip and bring the 4 over to this side, what are we going to have to do?
Add.
Yeah, because we flipped which side our number's on, so we have to flip the operation. So that's working with the fact family. So try again. What would the fact family be?
16 plus 4 equals 9.
16 plus 4 equals n. What is n going to be, Shantrea? What is,
20.
yeah, 20. Now remember, when we ask ourselves the question, we just put that verbal phrase in. Michael?
A number minus 16 equals 4.
So instead of saying a number, we say what number? What number minus 16 equals 4. So when we ask the question, we're just writing out that verbal phrase, right? What number minus 16 equals 4? What number would that be? Rhoda? 20. Now we're going to try doing it with our opposite operations. What operation is happening originally? Jack?
Subtraction.
Subtraction. What's the opposite of subtraction, Jack?
Addition.
Addition. So I know this is subtracting 16. I want to zero it out. So minus 16 is like saying negative 16. If we're at negative 16 on the number line, and we want to get to 0, negative 16 plus what gets us to 0? Fernanda?
16.
16. So negative 16 plus 16 brings us to 0. Whatever I do to one side, I have to do to the other side. What is 4 plus 16? Everyone?
20.
Now I bring down what I haven't used yet. I haven't used n yet. Minus 16 plus 16 zeros out. I don't need to bring that down because n minus 0, n plus 0, it's still just going to be n. And that equals 20. So we get the same answer for all those methods. Any question on any of those methods? Haley?
For on the, you have to write the, what is it called, the question on the left or the bottom. Like if you're doing on the back, if you're doing the bottom.
If you're doing the logic, you have to write the question. If you're doing the fact family, you have to write the fact family that you use to solve it. If you're doing opposite operations, you have to do the opposite operations. So this is one method, this is one method, and this is one method. So whichever method you use, you have to fully write it out. You cannot just give an answer. You have to tell me how you found that answer, which method you used. So show your work. So some of it, we're doing mental math in our head. Write it down on the paper so I can see it. So let's look at this last one. N minus 14 equals 71. Who can tell me one of those methods? Did you want to try it, Matt? You sure? I know Michael and Rhoda know how to, because they've been working other ones out. Does anybody new want to try? Vinny?
That would be 71 plus 14 equals 10.
So that method is the fact family. So he flipped it around and knew the fact family to get that answer would be putting the 71 on the opposite side, so we flipped that minus to the adding, and he found that 85. So that's the fact family. Anybody want to take a guess what the question would be? If we were reading that out loud, what would the question be? Matt?
What number minus 14 equals 71?
Perfect. What number minus 14 equals 71? And that would be our 85. 85 minus 14 equals 71. Let's try the opposite operation. Who wants to walk me through what to do? N minus 14 equals 71. What do I do the opposite of? Give it a try, Alex.
14 plus 14, and then on the other side you add 14.
So the only thing I'm going to clarify is it's not 14 plus 14, it's negative 14 plus 14. So we have to see that that minus stays with it. So it's actually negative 14 plus 14, that's how we get to the 0. Okay, so negative 14 plus 14 is 0. Oops, I'm using the wrong number. Is 0. So I end up with just n, because that zeroed out. 71 plus 14 gets us the 85. Now, up top, it says you can check your answer. How do we check our answer to make sure we did our math correctly? Jack?
I kind of put it back to the problem.
Put it back in the problem. So here I would say 14 plus 11 equals 25. So 14 plus 11 is 25. 25 really truly does equal 25. I did my math right. Woo. Next one, we would put 20 minus 16 equals 4. 20 minus 16 is 4. 4 really truly does equal 4. Did my math right. And over here, we would put 85 minus 14 equals 71. So I'm going to do this math. 85 minus 14 is 71. 71 really truly does equal 71. So take your answer and put it back in for the variable and make sure one side of the equal sign actually balances out and equals the other side. Okay? So let's look at our second page, our work page for today. Our directions say which method is your favorite. Use it to solve the equations below, and I'm going to tell you, you don't have to just use one method the whole time. You can decide which method works for which equation. Sometimes you might want to write out the logic question and then put the answer. Sometimes you're going to write out your fact family and put the answer. And some of them you might go, ooh, I want to try that opposite operations on this one. See if I can do it, because I know I'm going to have to do it eventually. Let me practice on a couple of them. You don't have to use the same method, but you do have to show your work. So you have to show me what method you're using. You either write out the question, write out the fact family, or write out the opposite operations and do the steps. Down below, we have a question. Using addition and subtraction each once, you're going to write two equations. So 2 equations for addition and 2 equations for subtraction with a total variable value of 5. So does our equation equal 5?
No.
No, our variable does. So n equals 5. N needs to be in the front part of that equation. So I could say something like 7 plus 5 equals 12. Now I'm going to replace that 5 with n. So that is one equation. Do you see how I got that? I used that variable value of 5 in that front part, either with adding or subtracting. And then I took the 5 out and I put my n in for it. But here's the trick. It has to be a part of that addition or subtraction. You're not going to put the answer is n. Okay? You have to put n with the adding or subtracting part. I don't want to see 9 minus 2 equals n. Okay? We don't want n by itself on the other side of the equal sign. We want n on the front side. Does that make sense? So write an equation using 5, 2 with adding, 2 with subtracting, different equations. You take out the 5 and you put in the n. So I gave you 1. You need to do another addition and 2 subtractions. Okay? Any questions on today's work? All right. You're going to quietly work. I'm going to be passing back math packets. I've already passed back, I think I've passed back all of the practice works that I corrected. I'm correcting and passing back math packets. We've got 10 minutes of work time. This we will be correcting, today's Thursday. We will correct this on Monday. Tomorrow is a retake day. So make sure you get those practice works turned in so we can get right into retakes tomorrow. If you have no practice works to do, you can be working on that math packet. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day. Don't forget to like and subscribe.